Today we are going to see the new point from chapter 2nd, that is mechanical properties of fluids, and in this we had seen already what is surface tension and what are the shapes of the meniscus when liquid is in contact with solid. Okay, after that today we are going to see shape of liquid drops on solid surface. Shape of liquid drops on solid surface. Now, if a liquid which is dropped on a solid surface, what will happen? Either it will spread or there should be a drop or it becomes a spherical shape. For example, water is spread on a table or on a plain surface, then what happens? It will be spread. Okay, and at the point of contact it takes the spherical shape. Then if mercury falls on a surface, plain surface, then we had seen that there is a spherical bubbles. It forms such as a spherical shape. If we try to spread it, still it takes the spherical forms in the small droplets. Okay, then how it forms shape of the liquid drops on the solid surface, and it depends on the surface tension and the forces as well as theta, that is angle of contact of liquid with given solid surface. Angle of contact of solid with liquid for different substances is different, but it should be constant for that pair, that liquid solid pair. For example, pure glass, pure water with glass surface, there should be the angle of contact is equal to 0. Okay, then kerosene with clean glass, the angle of contact is 26 degree. It should be remain constant. Then how it going to form, we are going to see now. For that purpose, consider theta is angle in between solid liquid interface. Okay, theta is the angle in between them. Then suppose T1 is surface tension, for the pair that is solid liquid interface. For that purpose, consider this diagram, then you will understand more better. Suppose this is a solid surface. What is this? Solid surface. Now there is a drop of liquid which falls on this solid surface. This is the angle of contact theta in between them. Then this is T1, this is T2, this is T3. Okay, this is solid, this one is liquid, here is air. So what is this T1? T1 is nothing but surface tension for the pair of solid liquid is in contact. T2 is surface tension for air solid interface. Air solid interface. And T3 is surface tension for air liquid interface. Then formation of the liquid drop depends on this surface tension, and for that there is one equation, that is T2 is equal to T1 plus T3 cos of theta, since theta is the angle in between them. Therefore T2 is equal to T1 plus T3 cos of theta, which is nothing but T2 minus T1 is equal to T3 cos of theta. Therefore cos of theta is equal to T2 minus T1 divided by T3. This is equation number first. From this we can find out the angle theta, that is angle of contact. For that purpose there are three cases. That is, first case is this one. What is that? Acute angle. There is formation of acute angle. When there is the formation of acute angle, in such case, see this, if T2 is greater than T1, surface tension T2, that is given here for air solid interface, this T2 is greater than T1, and T2 minus T1 is less than T3. T2 minus T1 is less than T3. Therefore what will happen? This is less than T3. Then value of cos of theta is positive. Then the value which we get is positive, and therefore the angle made in such contact is acute. That means there should be T2 greater than T1 and T2 minus T1 will be less than T3. This is the first case where there is the formation of acute angle, and the shape of drop should be in this way. That means it will be spread on the solid surface. Second case is there, and it is case second, obtuse angle. When there is the formation of obtuse angles. Now once again consider, suppose this is solid surface and the formation of drop is in such a way, that means spherical shape. So such happens in the example of mercury, which does not wet the solid. Therefore this angle is obtuse angle, that is theta. Consider here is liquid, that is mercury. Here is solid surface. Similarly here T1 interface in between liquid solid. This is T3 interface in between air liquid contact, and this T2 which is air solid contact. For such cases there should be T2 less than T1. In this case T2 should be less than T1. So this case second depends on the surface tension, that is T2 is less than T1 and T1 minus T2 is less than T3. Then cos of theta is negative and the angle of contact is obtuse. So this is another case. In this case T2 is less than T1 and T1 minus T2 is less than T3. So this equation which we had seen that T3 is equal to T2 minus T1 divided theta, which is equal to T2 minus T1 divided by T3. In this equation, this T1 minus T2 which is less than T3. T3 पेक्षा लहान आहे आणि T2 is less than T1. म्हणजे ही येणारी व्हॅल्यू काय आली? निगेटिव्ह आली. येणारी व्हॅल्यू निगेटिव्ह आली म्हणून त्याची व्हॅल्यू काय येणार आहे ऑब्ट्यूस येणार. नाव केस थर्ड. So in this shape of liquid drop is circular or it takes the spherical shape. Then case third, in such cases if T2 minus T1 is equal to 0. If T2 minus T1 is equal to T3. That means T2 minus T1 is equal to T3. T3 will get cancelled. Therefore cos of theta is equal to 1. Therefore theta is equal to 0. That means angle of contact is equal to 0. Such example is shown in water, pure water which is in contact with glass. Next one more, that is case 4. In this case, if T2 minus T1, in this case T2 minus T1 is greater than T3. T2 minus T1 is greater than T3. T2 minus T1 is greater than T3, or T2 is greater than, or T2 is greater than T1 plus T3. Okay, in this case what will happen? See, T2 minus T1 which is greater than T3. If it is greater than T3, the value of cos of theta should be more than 1, and this condition should not happen, and then that time there should not be formation of a liquid drop. It will spread all over the surface of the solid, and this is impossible. So the liquid spread over the solid surface and drop will not form. In this way there is the shape of liquid drops on solid surface. Okay, then next one more, that is liquid solid pair and angle of contact. Liquid solid pair and angle of contact. First one, pure water with glass, with clean glass. It is 0. Then chloroform with clean glass. Second one, chloroform with clean glass. It is also 0. After that, ether with clean glass. Ether with clean glass. It is also, no, it is equal to 16 degree. Then kerosene with clean glass. With clean glass, it is equal to 26 degree. Then water with paraffin. Fifth one, water with paraffin. It is 170. Then mercury with clean glass. Hg with clean glass, it is equal to 140 degree. So this is liquid solid pair and angle of contact. That means it depends on shape of liquid drop depends on angle of contact and that liquid solid pair. Afterwards, effect of impurities and surface tension. Effect of impurities and surface tension. Is that impurities effects on surface tension. That means the effects on angle of contact, the effects on angle of contact, then that angle of contact effects on surface tension. So first one example is there, that is if common salt, that is effect of impurities, soluble impurities are there such as common salt, sodium chloride. If it is dissolved in water, then what happens? Surface tension increases. We cannot drink this such solution. Why it's so? Because its surface tension is very high, or surface tension increases when we add NaCl in water solution. So due to these impurities, surface tension of water increases. Second one, phenol or detergent. This is also soluble impurity and it is mixed with water. Then what happens? Surface tension decreases. In this case, when phenol or detergent is added to water, then surface tension of water decreases. And because of this tendency, we are using the detergent for washing our clothes. Okay. And for washing, that is, it is main important thing that we are using in our daily life. Then this water makes good contact when its surface tension decreases. So it makes contact with the fabric at each and every point. So our clothes should be clean. This is soluble impurity. That means in this case we had seen first one, soluble impurity. Then another one is insoluble impurity. In insoluble impurities there are mercury. It does not dissolve in water. So or dust, it is also impurity. When dust is added into water, its surface tension decreases. Then if dust is added in mercury, then surface tension decreases and does not form droplets. When that dust particles collect on the mercury surface, then there should not formation of the liquid drops. So this is the effect of insoluble impurity. So insoluble impurity decreases the surface tension. This increases surface tension. In this case it decreases surface tension. Soluble impurities मध्ये कॉमन सॉल्ट असेल तर तो काय करतो? सरफेस टेन्शन इन्क्रीज करतो. देन इफ देयर इज अ detergent, it decreases surface tension. Okay, next one more point is there, that is effect of temperature. Effect of temperature on surface tension. On surface tension. What is the effect of temperature on surface tension? If temperature increases, surface tension decreases. So this is also used in case of washing of clothes. If there is a new cotton cloths, we cannot use highly temperatured water. There should be washed with the cold water. But if such clothes are there, that is very tough stains are there, then that time we can wash our clothes with the highly temperatured water. Okay, so this hot water remove tough stains. Since its surface tension decreases as temperature increases, surface tension decreases. Since surface tension decreases, angle of contact also decreases. Angle of contact decreases, so surface tension decreases. So this is all things. After one more remaining factor is there, that is surface tension becomes 0 at critical temperature. Surface tension becomes 0 at critical temperature. So we are using detergents for washing clothes, then we are using highly temperatured water for washing our clothes. One more thing is that is toothpaste, which we are using in daily life, that spreads all over the teeth in our mouth, right? So it reduces the surface tension of the water. So our teeth should be clean. Okay. Then factors affecting on angle of contact. Which factors are there that affects on angle of contact? That is, first one is nature of liquid and solid interface. First one is nature of liquid and solid. Which liquid is in contact with solid? Depending on that, angle of contact depends, and depending on that, surface tension depends. Second one factor is there, that is impurity. Impurity affects on angle of contact and surface tension. One more thing, that is temperature. This temperature also affects on surface tension as well as angle of contact. Okay, thank you.